Hello everyone, this is Prashanth. Let's continue with the last lecture here. So I'm going to discuss about the new topic, that is IoT architecture. So before entering into the actual content of the present slides, so once we recall last two session topics here. So in the last session, just we have discussed about netopir in the terms of IoT networks and machine-to-machine communication technology. So, in the Netopir, we have discussed about the introduction part of Netopir. What are the specifications, important specifications of Netopir? What are the advantages? What are the applications? What are the requirements of in order to build Netopir communication? Like that, we have discussed in the last session. So now we move entering into the another topic, that is IoT architecture here. So first. Let's start with what is IoT architecture. What are the contents? What are the specifications IoT architecture include? So along with the different layers we have, perception or session layer, application layer, network layer, processing layer. Like that, we have four types of network layers in IoT architecture, and along with the stages of IoT solutions architecture, and some key components of IoT architecture we have. So here these are the important topics we are going to discuss right now. So this is IoT architecture in just generic diagram of IoT architecture. So let's start with there is no single consequence of IoT architecture in IoT. For it is different. We have IoT architecture means what? Compulsory we have different stages, one layer, two layer, three layer, like that. So in IoT architecture also we have different layers architecture. First we have going to discuss about three and five layer architecture. Next, cloud and fog based architecture. In social IoT, basic components and representative architecture here. Social IoT basic components and representative architecture here. Let's start with 3 and 5 layer architecture here. So 3 and 5. So in 3, under 3 we have three layers. In 5 layer we have 5 layers, like business layer, application layer, processing layer, transport layer, and perception layer. In 3 layer, application layer, network layer, perception layer. This is 3 and 5 layer architecture of IoT. So in 3 layer we have perception layer, network layer, and application layer. So in the perception layer, what are the main function of perception layer here? Which has sensors for sensing and gathering information about the environment. It senses some physical parameters also. Some physical parameters are identified other smart objects in the environment. So just it can deal with the environment. So which parameters we are going to measure in a environment. Next, network layer. So the main responsibility of network layer is to other smart things. Some smart things, network devices and servers, and its features are also used for transmitting and processing sensor data. So this is about network layer under 3 layer architecture of IoT. Next, application layer. The main responsible for application layer is specific services to other users. It defines various applications in which the Internet of Things can be deployed. So we are so many applications included in the IoT domain specific. So among that, just it can deal with some applications. Deployed applications can deal with the application layer. So these are the 3 layers of IoT architecture, that is perception layer, network layer, and application layer. Next, cloud and fog based architecture here. So in cloud and fog based architecture, like 6 layer, a transport layer, security layer, storage layer, processing layer, and monitoring and physical layer we have. Just it can start with top to down, with physical layer, monitoring layer, pre-processing layer, storage layer, security layer. It can provide some security protocols also. We have to store some information in the cloud. We have to process the information from transmitter to receiver, like already monitoring layer also available. So here in some architecture, the data processing is done in the large centralized fashion by cloud computer. So compulsory from transmitter to just receiver. After receiving, it can analyze the data. After the analysis is over, compulsory we have to store the information in the cloud. So here, such that phenomena, the cloud-centric architecture, it keeps the cloud at the center, applications above it, and it network of smart things below it. So here, the cloud computing is given primary because it provides great flexibility and scalability. So in order to enhance flexibility and scalability, it can provide both features of a network, flexibility and scalability. It offers services such as that core infrastructure, platform, software, and storage. So these are some points. Next, developers can provide their storage tools and software tools, data mining, machine learning tools, and visualization through the cloud computing. So these are the about some points regarding cloud and fog-based architecture before entering into the actual architecture of IoT. So next, basic components. What are the basic components I mentioned in the first slide here? Identification. Just we have to any other elements or any other network or any other devices. First, we have to identify the main number of networks. So here we need a unique method of object identification. An ID can be assigned to an object and traditional parameters such as like MAC ID, IPv6 ID, or IPv4 ID. So compulsory every device having one unique ID. So that is in terms of either IPv4 or either IPv6 or MAC ID, like that we have. So it is universal code like that. The first point. Next to maintain information. Meta information along with ID. So we need some meta information about the device that describe its form and operation. So for example, one system. So this is one system here. So the MAC ID for the system is like 100.1 or 2.0, 2.3. So along with the IDs, compulsory it have some meta information. So here like that, this is required to establish appropriate relationship with the devices, and also appropriately placed in the various of the IoT devices, inverse in IoT devices. Next is security controls. So compulsory for stored information, we have to provide some security protocols also. This is similar to friend list settings on Facebook. On owner of a device might place restrictions on the kinds of devices that can connect to it. So these are typically referred to as owner control. Compulsory either in Facebook or in Twitter or any other social media website. Compulsory we have one login. So login means compulsory we have one page. So for that page we have to provide some security restrictions also. So some other people are want to see, so they can ask the permission from me. They get permission from me. Otherwise, it unable to see on my page, either on WhatsApp or Twitter or any other social media website like LinkedIn, like that. So same security control also, like friends list, it stores on Facebook. Which is service discovery. So here, which type of services can provide us? It can a system is like a service cloud where we need to have dedicated directories that can store details of devices providing certain kinds of services. It becomes very important to keep the directories up to date, that such devices can learn about the other devices. So this is about service discovery and relationship management. So here in relationship management here, so it with the help of other devices, it also store the types of devices that can give given devices to try to connect with based on the types of services provided. Which type of based on these services provided to us, So based on that, the relation can build with the devices. Next, service composition. Next, service composition, if it takes social IoT model, a new model, it ultimate goal of having such a system is to provide better integrated services to the user. So this is the main function of service composition, that is comes under IoT components, basic components: identification, meta information, security control, discovery, relationship management, and service composition. So these are the some basic components including IoT architecture. So here, so the main, what is the main architecture of IoT here? So currently, IT market is a full of new concepts such as data science, like data science, analytics, artificial intelligence, EA and ML, machine learning, deep learning, like that we have. Such new concepts came into force IoT, but the question is to what the actually is mean. So the Internet of Things refers to the widespread interconnection. Widespread interconnection. So where the internet is available and the earth anywhere go, just you can go to the internet. So widespread interconnection of various devices such as wearables or watches, tablets, remote controller sensors, home appliances, and more with the people who can utilize them. So especially the solution gathers data from the large number of devices, which it can then send to the data centers and servers for other analysis, which drivers automation and action. So anywhere go, just you can car, you can system, or in a house, in a company, where it is go, just you can where the in anywhere on the globe. So the internet is available. Compulsory that internet can connect to the devices. So from the devices, connected devices, just we have to gather some information. So the gathered information we have to send to the destination part. After storing in the cloud, so we have to analyze the data. So the analyzed data, according to our requirement, we can use it. This is the process. Just you can go anywhere. It's a minimum process will happen. So next, different layers of IoT architecture here. So like this is a four-layer architecture. So here up to now we have discussed about three to five layer architecture. Next to six layer architecture also indirectly. So six layer architecture also we have discussed. So now this is the four layer architecture here. So in four layer also some layers depends on the requirement of the customer. So application layer, data processing layer, network layer, and session layer here. Same layer, but here one data processing layer is extra here. So session layer for gathering of data from the IoT connected devices. Next to the network layer for data transmission. So gathering data we have to transfer from one place to one device to another device. Data transmission. Next to process. So process next to analyze. That means depends on the application it can use. So here a complexity and a number of architectural layers vary according to the specific business task at hand. A four-layer architecture is the standard here. So the data flow from here to here. Sensing layer, so already know physical objects, sensors and actuators in order to gather the data here. So next to network layer, in order to data transmission we use some gateways, like gateways are network internet gateways or network topologies, like star topology, mesh topology, ring topology, bus topology, like that we have so many 5 to 7 types of topologies also we have. Next to data processing layer, processing unit, and data analytics are decision making devices. Next to smart applications and management, like real time applications of layer. So these are the four stages of IoT architecture: application layer, data processing layer, network layer, and sensing layer. Next, let's start with first layer here, perception or sensing layer here. So the first layer of IoT system involves things. Things is nothing but devices or sensors or actuators. So these are the thing endpoint devices that can serve as a conduit between the physical devices and the digital one. So the room, so here the room is here. So the room is a physical room. So here, in order to measure the parameters like temperature, humidity, like that parameters we have to record. So for that we have temperature sensor, humidity sensor, like that some physical end devices we need. So perception refers to the physical layer, which includes sensors, actuators that are capable of collecting, accepting and processing data over the network. So we already discussed in last slide. Sensors and actuators can be connected either wirelessly or via wide connection. The architecture does not limit the scope of its components nor their location. So this is the about perception or sensing layer. Next, network layer. So in the network layer, it can provide the it can provide the overview of how data is moved throughout the applications. This is layer contains data acquisition system (DAS), data acquisition systems, and the network or internet gateways. So the DAS perform data aggregation and conversion functions, collecting or aggregating data from sensors, then converting analog information to digital form. So like A to ADC, analog to digital converters. So it necessary transmit and process of data collected by the sensor devices. That's why the network layer does. So it allows devices to connect and communicate with the other servers, smart devices, and the network devices. As well, it handles all the transmission for the devices. This is about a network layer under the data acquiring systems. Next to processing layer. So the just we have to process the data from devices. So the processing layer is the brain of the IoT system. So like for computer, the CPU is the brain. So for the here the processing layer also brain of the IoT system. So typically, data is analyzed, pre-processed, and stored here before sent to the data centers, where it is accessed by the software applications, both monitor and manage the data as well as prepare for further actions. So this is where Edge IoT or Edge analysis enters the pictures. So this is about processing layer. Next, application layer. So after the last movement, the last point is application layer. So in order to develop the real-time applications here, so user interaction takes place at the application layer, which delivers application specific services to the user. So an example might be a smart application, home application, where users can turn off on a coffee maker by tapping a button in other app that shows the status of the devices. So in coffee machine, for example, the tea powder or coffee minutes are going to end. So it automatically send the information to the source. So the coffee powder is going to end now. Just you can refill in the given time. So like that, the information may pass through from the source. So here there are many ways to of internet of things can be deployed, such as smart cities, smart homes, and smart everything. Everywhere we can use IoT. So these are the four types of layers: sensing, network, processing, and application layer. So the last one, stages of IoT solution architecture here. So we have some solution for a particular problem in IoT. So the Internet of Things may be referred to connected devices and protocols, but in reality, the data from these devices is soiled, fragmented, and isolated. So soiled, fragmented, and isolated. Just we have to decrypt the data or decode the data. Isolated data we can fetch the track the data from the bunch of data. Such as these fragmented insights alone do not provide enough information to justify an IoT strategy that involves a significant investment of resources here. To capitalize on IoT, enterprises must also these devices interact freely. They must maximize device systems synergies. So here, so in order to solve the stages of problem solving, So here devices, internet gateways in order to develop the communication among the all IoT associated devices. Next, edge or fog, that means cloud. In the cloud, next cloud. So here these are the IoT solutions. Here first we'll start with IoT connected devices. This is the solution. So here the first step towards IoT architecture, the physical layer must be established within the environment. So here the connected device, this is the tower. So here there are many devices to connect it to the this tower. So there would be Internet of Things without smart or connected objects. Typically, there are wireless sensors or actuators in the perception layer. So the local area network, by example for object, connected objects, local area network or personal network can be used for connecting our actuators. So compulsory, we have to develop the communication among the connected devices. So the connected devices means compulsory with the internet only, with the help of internet only, the devices may be connected to the one to one. So that is possible with in connected objects means that is possible with local area networks and personal area network, LAN and PANs. Next, internet gateway. So in order to develop the communication or pass the information from one place to another place, here we have internet gateways or internet Wi-Fi, so wireless or wired communication. So here as the sensors and actuators collect the data in analog form, we must have the meaning of ADC. So the analog information can be connected to the can be converted into digital form. Digital form. That's why we need ADC converter, analog to digital converter here. So in the gateway, the stage, so the raw data will be received from the devices. So the pre-processed before sensing sent to the cloud. That data acquisition can be used to convert the analog to digital form. So data acquisition system DAS. So the DAS is used to ADC. Data acquisition system can be converted to analog to digital form of information. So it can connect it to the sensors and actuators and gathers of all the data, converting into digital form so that it may be routed over the network by the internet gateway. So like this is the just an example diagram of internet gateway. So next to IoT edge system. So edge computing, here we have different devices in the system. So the significant small amount of data collected by the IoT system and the consequent bandwidth requirements, edge IoT system play a crucial role in reducing the pressure on the core IT infrastructure. Directly sending data to the server or the data center will cripple to speed of the system as well as bandwidth of the LAN or routers of the system. This is IoT edge system. Next, the last one, data centers and cloud storage here. So after the data has been successfully properly pre-processed and analyzed, so all loopholes have been removed and the data sent to the data centers and servers are final analysis and reporting. So just we received the some bunch of data, certain amount of data. So the received data having some loopholes. So that can be removed by after removing the loophole only just the data centers can receive the actual data and it store it. Data centers and cloud service fall under the management service category and usually process data through the analytics, device management and security controls. So furthermore, the cloud also enables the transfer of data and end user applications to the like healthcare, retail, environment, energy, and emergency, etc. So just data centers and cloud storage, just the graphical representation of data centers and the cloud storage. This one. The next, the last one, the key components of IoT architecture here. So the main key applications and analytics components. Compulsory, we have to develop the some real-time applications like mobile application. So here security, it can provide some security protocols also, security and management control, management components like integration component and infrastructure component. So the in terms of applications, we have some many companies like Amazon, Google, like some vendors of application tools like Salesforce like that. We have some application. Just in terms of security and IoT management component, so like yeah, ARMIS authorization zero, Cisco or DG set for skirt order that, like we have some management components also. Next, integration component. So this part makes sure that the infrastructure security and tools all work together with the company's current ERP. It must to follow the management systems in the efficient manner. Next to infrastructure, so we have to develop the infrastructure here. These components are real things like sensors which gather the data, actuators will regulate the movement. It refers to the network which is not commonly as a like a wireless network. For instance, Wi-Fi, Bluetooth, 4G, 5G like that. We have some are situated. So the IoT architecture can be used to explain how this technology operates in various situations. So here, various situations here we have one, two, three, four, three situations here. So IoT design for aviation industry. So the different situations like that. First one, aviation industry. Next, manufacturing and Microsoft Azure. Manufacturing industry, and Microsoft Azure. So here, different situation. Abusi Airport may have hundreds of moving vehicles, both aeroplanes and ground vehicles, like at a given time. So these movements need to be made across several square miles of terrain increment, whether the limited visibility. It depends on the whether they can land or not. So this is one of the in this situation IoT solution assist airports in strengthening safety, enhancing efficiency, reducing. So in order to protect this type of aviation industry situation, so the IoT will help assist our airports in strengthening safety, enhancing efficiency, and reducing interruptions. So this is the one of the real-time application of IoT in aviation industry. Next, manufacturing industry also. So it will help. It helped Stanley Black Decker identify the locations of issues on its factory floor. It works by attaching RFID tags. So RFID tags is nothing but compulsory. It can work with internet only. So the it is goods moving through the manufacturing facilities. So this type of help will provide through the internet in the manufacturing industry. So next to the last situation here, Microsoft Azure. So here Azure IoT platform consists of cloud services that can connect to track and manage billions of IoT devices. Particularly Azure IoT provides for a bidirectional connection between the devices and application. So here this type of situation it can provide by as a result of Microsoft offers can complete solution to manage all IoT architecture layers from devices to the application. It can provide single solution based on the requirements here. So it can provide manage all the IoT architecture layers from the device to application. So this is the third situation in the Microsoft Azure architecture in the cloud in every floor of the building. So situation 3. So these are the how these technologies, IoT technologies can protect the movements in every various different kinds of situations. So these are the in the parts of IoT architecture. Remaining continue with the next class. So these are the some references I referred for this lecture. Interviewbit.com one side and the IoTacademy.co. In the second references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.